Hello everyone, welcome back to the TechART Learning Hub. I'm Preeti Boddeti, and in today's session we'll be stepping into one of the most exciting parts of generative AI, that is agents. You've probably interacted with chatbots or used LLMs like Gemini, GPT, Llama, Claude, and so on, where they've given best answers based on the user input. But what if I told you that these LLMs can go beyond just giving answers? Imagine if they could behave like a digital teammate where they just not only respond but actually thinks, plans, decides, and takes actions on your behalf. So that's where AI agents come into picture. AI agents are the next evolution of LLMs where they combine reasoning loop, memory, and tools to interact with the world around them. So today in this session, we'll talk about what agents are, what are their best features, and how they've become the next big step beyond LLMs. Let's start with the basic question, what is an AI agent? In simple words, an AI agent is upgraded version of an LLM. Normally, when the user gives an input to an LLM, it gives the better output. That's where the conversation has ended. But when it comes to the AI agent, it goes beyond that, where it goes through 4 different phases. Firstly, observing its environment. Next, choosing what action it has to take. Third, executing that action using tools or APIs. And at last, reflecting on the results. So, the agent observes what its current situation is or what the context is about. It could be a user input or the results from the previous action or the data from the database or a file. So, it observes the context, and in the second phase, based upon the context, it chooses what action it has to take. Once it has made its decision to what action it has chosen, then it performs the third phase, which is execution. It executes that action using tools or APIs. And after this execution, the results are attained. So at last is the reflecting on the results, which is the agent doesn't stop at attaining the results, but it checks what the flow has happened, what actions have been made, and what the end result has been achieved. And at last, it also checks whether the result is appropriate based upon the context it has been observed. And based upon that feedback, the agent adjusts its next steps so that it can make better decision making further. So this is what the AI agent's background work. So in general, I could say that the AI agent inculcates features like memory, LLM, reasoning loop, and at last is the tools. So I can conclude that an AI agent is not a chat model, but it is a system that can reason and act autonomously. Now let's talk about what makes agents more powerful. Agents bring several key features to the table. The first is memory. They can remember previous tasks or actions. The second is tools. Tools help us to connect with APIs, databases, or external applications. The third is the reasoning loop. They don't just respond once, they observe, think, and act repeatedly. And at last is autonomy. They can execute multiple actions until a goal has been achieved. So, these features together help in creating an automated workflow where the model is not just chatting but actually doing some work intelligently. Now that you got to know about what agents are and the features that make them more powerful, now let's move on to a quick, simple, hands-on example to see how the actual flow works. Before we dive in, it's good to know that agents work better when built using frameworks. So these frameworks help with the structure, memory, and tool integration. We'll discuss about these frameworks later on in the upcoming videos. As of now, let's keep things simple. We will build an agent from scratch by using the basic tools and logic and see how each step of the agent works. So let's start with our hands-on. We will build a tiny simple example which is a weather-wise advisor where it is going to take the destination's details and it is going to predict the weather there, and based upon the weather's data the chat model is going to give us what necessities we need to pack. So I'll just walk you through the code and we'll see how the process goes using the tools with no framework, and see how this agent is going to work accordingly. So without further delay, let's get started. So this is the code for the weatherwise advisor, and before we jump into the code, I just want to quickly mention that I've recently moved from Visual Studio Code to the Cursor. It's a really good IDE. It's simple and lightweight, and most probably it's AI friendly. So just like in Visual Studio Code, I just created the virtual environment and then just activated it, and then I've installed the dependencies, and along with that I also installed Jupyter so that I can interact with the notebook files. That's what I've done. I've created a notebook file so that I can maintain the Python code in separate cells and then run them step by step and see how the agentic flow works. So yeah, let's start with the code and see how the flow is working. If you all are interested, just give a try in Cursor and see how this helps. If you all have already done the Visual Studio in setting up the virtual environment and activating it, then you all can try this part. If not, then check into my previous tutorials where I've done the AI codes, the chat models in the Visual Studio, where I've set up the virtual environments and activated it. Yeah. So let's start. Here in the first segment we have installed a few of the dependencies that we need. One is the OS, where it's going to handle the environment variables, and the Gradio, it's a lightweight UI interface. If you all want more details, we have a video for that too. And then the OpenAI, this is the LLM which we are going to interact with to fetch our desired goal, and then the .env file to maintain the environment variables. So we'll just run shift and enter and it's just gonna run. Yeah, if we get a tick mark, it shows that it's successful. And then moving on to the next segment is the loading the environment variable from the .env file. I have a .env file, I just don't want to open it because I have the confidential data, which is the OpenAI key. So I hope everybody is familiar with that. If you are not, then please refer to one of our videos possibly. And then I've maintained the OpenAI key in the .env. I'm just fetching that API key and checking for its existence. So just let's run that shift and enter, and it's successful. So it says OpenAI API key exists. And then moving on is we have used the first tool, which is get weather. We are just using the mock data as of now, since it's just the basic simple way with no framework structure for the agentic way. So here is we are using the mock data for the cities like New York, London, Tokyo and Paris with its respective mock data, which is showing the weathers and their temperatures, and then we are just returning it the mock data, and we are doing them in the lowercase letters. And here when the user will give the prompt about what weather details it needs for that destination, then the LLM is gonna trigger this method, the tool, and based upon that user given city, it's going to check whether that city is present in this mock data, and then it's gonna return the details. That's what the flow is. And the same way, we have another tool which is the packing suggestions. As I told you all earlier, that depending on the weather details, it is going to suggest what necessities we need to pack. So that is what, when the weather has been given by the model uh, from the tool, then it is going to fetch, if it is sunny, then please pack these set of things. If it is rainy, please pack this set of things. So it is just checking on the keywords. Based upon the weather keywords, it is returning some set of necessities. So that is what this tool is gonna do. And then moving on is the main and the most important logic, that is this agent. So here I've mentioned the travel agent, where we get the user input, and most importantly we need to maintain the history, because that is what the no framework is all about. We need to allow each and everything from scratch. We need to structure things so that the LLM works like an agent. That is what a no framework means. Manually you need to develop each and everything. So here I have also maintained history, because since the agent needs to remember the state, it whenever it goes from one transition to the other, from one step to another, it also needs to keep hold of the memory, like it has to keep hold of the history. Based on that context, it can go and it can decide and it can reason accordingly, and it can choose which tool and which action it has to proceed, so that we can get our desired goal. That is what agents do. So we are just structuring it in that way. So in this travel agent, the same way like we used to do the chat models, we always need to define the role for the chat model, like whether you need to be in a professional way, and how you need to act, and what if the user gives an input, how do you need to do accordingly. So we are just structuring it, since it's a no framework. I hope you all are just able to relate. um, so here I have maintained the role system, and then the content is, you are a friendly travel weather assistant, and your job is to provide the weather information for the city given by the user prompt. And then always first check if a packing tool is available. Do not generate packing advice yourself if the tool can provide it. So you just don't rely on your own knowledge. Only do that when you have no tools with the relevant information. And then provide a clear, concise weather information, including the expected weather, approximate temperature, and general conditions. After providing weather, the packing tool will generate the recommendations. Only provide packing advice yourself if the tool cannot. Okay, and be polite and concise. That's what we are training the model to act like when the user prompt is given. And in here we are including the previous context as well in the history, because the LLM model should have to remember what the context is earlier, so that it could proceed for the next step. If it doesn't maintain that state, then it is going to provide hallucinations, and we will never ever going to get our desired goal in an agentic manner. So then the whole system just crashes. It makes no sense. So yeah, so here we are just giving the user prompt, the bot response, and we are including their context, the conversations they had earlier in the history, so that the later steps, it will use that context, and then it will proceed further with what actions to perform. And then we are maintaining the reply with the empty string, so that we'll just get the next response. And as of now we have toggled the city found variable to false, and we are going to check if the user prompt has given for say we mentioned some static mock data with 4 cities, so that's New York, London, Tokyo and Paris. If the user gives or asks for the weather details for one of these 4, then we are telling to toggle it to true, like I found the city, I have that mock data readily available, so you can just refer to my tool. We are just telling, hey LLM, when the user prompt gives in one of these cities, then just use this tool that I've defined that holds these mock data. If it doesn't hold any of these 4, then please use your own knowledge and give your desired weather details. That's what I have given. And later on, after fetching the details either from its knowledge base or from the mock data by using a tool defined earlier, it's going to give us the temperature and whether it's sunny or whether it's cloudy or rainy or something. And based upon that weather keyword, it is going to go for the tool to check for the necessities that are required to pack. So when it's calling that tool, in that tool, if the weather keywords are relevant and they are present in it, then it's going to give that appropriate details that are mentioned in the tool. If not, then it is going to use its own knowledge base and it's going to give the user a response. So we have given a roadmap for the LLM. Hey, go for this route if the user prompt acts like this, or else go for the route B if the user prompt is giving this. So we are just giving the guidance to how the way should go, how it has to go, which route it needs to pick, which action it has to proceed and so further, but keeping the history by itself. So that is the process, and at last it's just gonna give us the reply from the LLM, and that we are maintaining in the chat interface, which is the Gradio. So I'll just run this entire tools and the travel agent logic as well, and then we will start running the Gradio interface and check how the flow is going. So I think we've stopped till the OpenAI check existence. So I'll just run this tool, and yeah, it just successfully executed. And then we'll go with the packing suggestions. So once you check my weather details, just please check what necessities I need to pack. And then further, this is the entire roadmap of how the LLM should act according to the user input. So be in an agent. Okay. There is some inundation issue, so we'll just see what is. Okay, I think this should go. I don't think we need this. Let me run it again. Yeah, it worked. And then we will run the chatbot. So yeah, let me click on this link and we will see how it's gonna work. So just a second. So I have mentioned as weatherwise agent with no framework, and ask about weather and what to pack. Agent uses tools and LLM reasoning. So it's not only the tools response we will be getting, it can also use its own knowledge and get some random answers too. So let's start with hi, and let's see what it's gonna respond. Hello, how can I assist you with your travel plans today? Now let's ask what's what's the weather in London? So let's see. In London, okay, yeah, in London we have the weather as 15 degrees centigrade and it's rainy. And then the flow will go directly to the next tool because it's just an agent. It's just not going to give a reply like it's so and so, and then again it's gonna expect us asking what necessities I need to pack. No, we have already given the flow predefined in the code itself. So since London is showing 15 degrees centigrade and rainy, let's check for the weather keyword rainy, and it's right here. So it has to tell like carry an umbrella, raincoat and shoes and a lightweight jacket if needed. So let's see whether we will get that. If you see, yeah, the weather in London is rainy, 15 degrees centigrade, and the packing tips is carry an umbrella, raincoat, waterproof shoes, and a light jacket if needed. So it has given some static details which we've maintained as a mock data in our tools. So we can improvise this with frameworks, and we can use the weather API so that we can get more accurate results and more dynamic way. So as of now, since no framework and we are just going with the base level, so just to know how we can build it from scratch and maintain in a desired structure, so we are getting such kind of responses. So yeah, we've just got it from the tools that we've defined. So right now we'll just go to the other route where the LLM uses its own knowledge and then checks whether based on the weather data provided, it will go to the tools and check if the relevant information is present in the packing tools. If there is no relevant tools information right in there, then it will also check for the necessities using its own knowledge base. So yeah, now we will check what's the weather, and let me check what mock data we have maintained. It's New York, London, Tokyo and Paris. So we'll just go to what's the weather in Sydney, maybe. Yeah, so let's see what response it's gonna give. Yeah, for Sydney in October you can expect weather generally warm, sunny and occasionally rain. Temperature range from 15 to 24 and conditions mostly sunny. So since it's telling mostly sunny, maybe it can predict from the weather keyword sunny, and maybe it's giving the packing tips based on the weather keyword as sunny. So let's see, it's like pack light cotton clothes, sunglasses, sunscreen and a hat and stay hydrated. So we'll just go to the packing tools and see, because there is no mock data for Sydney, there's no chance for it to go for this tool. It then just moves to the packing suggestions and checks for the sunny, and we have the keyword sunny, so it just returns the packing tip. So that's what we got, the exact info for the necessities that it needs to pack based on the weather keyword sunny. So that is the next else logic that we've maintained. If not city found, then it's going to use its own logic, and then using the regular expression, it is just going to check for the keywords. So it has picked the keyword sunny, and if there is a match found, that word is going to be given to the packing suggestions, which is given to the weather variable, and then we are just going to get that reply, and at last that response will be given from the chatbot. So that is what the flow has been made. So this is all about the weatherwise agent with no framework. The main thing in here is we need to maintain the history every now and then to each and every step the execution flow goes on. because that is how, based on that context only, the LLM can work accordingly. That is what we've learned. The first step is context. It has to do the observation. Based on what it is observing, then only it can do, and it can then just decide which tools it needs to choose. And after it chooses the tool, it performs its execution, and based on the results it keeps improvising every time. So this is all the agentic flow with any use of frameworks. To improvise it, we can use that weather API, and when using frameworks, I every time keep telling no framework, no framework. But with frameworks, we can have the built-in history, that is the memory. We don't need to maintain in each and every step. Don't need to tag along with the execution. That makes the processing even more time taking. So we don't need any memory to tag along. And then apart from that, we can also monitor the execution step, like once the input is given, to which tool it's going, to which tool it's not going, whether it's going directly to the LLM, or whether it's using its own knowledge base, or it's just using some external resource. So that entire flow we can monitor if we are using the frameworks. That is one big advantage too. And then we'll just go along. We have lot of frameworks. We'll discuss about how it works with frameworks, and what are the different kinds of frameworks, and what environment they have, what features they have, and how we can improvise this application further. We'll just go into them in detail. That's it for this session. We just finished developing a simple agent with no framework. We have seen how the flow works and how we've structured it from scratch using tools. So this gives us a clear foundation, and before we move on to the next step, where we start exploring what frameworks are, what are the different types of frameworks, and how they make the agents even more smarter and structured. So we'll discuss about them in the coming videos. If you found this video more helpful and are also curious to learn more about the AI concepts, then please do like, share and subscribe to this channel.